This is video 5 for unit 7, and in the last video we talked about solving trig equations, and here we're going to talk about solving inverse trig equations. So let's start simple. Let's start with something like inverse cosine x, maybe 2 inverse cosine x equals pi. Okay, so similar to when we solve trig equations, we're going to think about, before doing anything, isolating that. Instead of isolating the trig function, we're going to isolate the inverse trig function. Okay, so let's do that by dividing by 2. And here's something that you do want to remember. So once you've isolated that inverse trig function, you want to check that, so it's equal to pi over 2. Pi over 2 stands for an angle, because remember the output of inverse trig is an angle. Check to make sure that this statement is actually even possible. In other words, does pi over 2 fall in the range of inverse cosine? And for inverse cosine, is it between 0 and pi? It is. Okay, so we can proceed. And so a good strategy, once you've isolated that inverse trig function, we're going to take the cosine, in this case, of both sides. Why? Well, in order to get that x out of the inverse trig function, if I take the cosine of both sides, I'm composing a function with its inverse. So I'm going to take the cosine of both sides. And remember what an inverse composed with a function composed with the inverse does. They undo each other. So cosine of inverse cosine of x will be x. So I've got x equals cosine of pi over 2, and cosine of pi over 2 is 0. So there's your solution there. Okay, so that was a decently basic one. What about, let's do something like this. What about inverse sine of x equals inverse cosine of negative 2/3. Well, negative 2/3 isn't, I can't find this angle, because negative 2/3, at least not the exact angle without using my calculator, negative 2/3 isn't correspond to one of my special angles. But I certainly can think about getting this, so I can't do anything on the right, but I certainly can think about, all right, I need to isolate x, so let's talk about taking the sine of both sides. So on the left I get x, and on the right again, something that we are familiar with solving from the inverse, from the section that involved inverse trig. So what I'm essentially doing is sine of some angle, because remember the output of inverse trig is going to be an angle. So let's draw the triangle that I would form associated with this angle here. So, and again, coming into play is knowing the ranges of inverse trig. So if I'm inputting a negative ratio into inverse cosine, I'm going to be in quadrant 2. So negative 2/3, and the y coordinate using the Pythagorean theorem will be 9 minus 4 in the square root of that, which is root 5. So going back to the problem, I've got x equals sine of this angle, and looking at my triangle, sine of this angle is root 5 over 3. So that wasn't so bad. All right, well, let's do something different. Let's do, how about inverse tan of x minus inverse sine of negative 1/2 equals, let me think of something, equals, so let's do pi over 6. Okay, I certainly can think about isolating inverse tangent of x, but I actually, unlike the previous problem, I actually know what inverse sine of negative 1/2 is, and you can bring it to the other side first, or you can just fill in what this is. And again, I know what that is. Inverse sine of negative 1/2 is going to be negative, oops, not equal to, sorry, shouldn't have put an equal sign in there. Minus, so inverse sine of negative 1/2 is negative pi over 6. Remember, the range of inverse sine is between negative pi over 2 and pi over 2. That's why I'm putting in a negative quadrant 4 angle equals pi over 6. All right, let's isolate now inverse tangent of x so I've got negative and negative, so that's positive. So to bring it to the other side, I'm subtracting. So I'm going to end up with 0. Now, is 0 within the range of inverse tan? It is, because remember the range is negative pi over 2 to pi over 2. So what would be the ratio that when or I can think of this, how about let's take the tangent of both sides like we did previously. So x equals tangent of 0, which is 0. Okay, so not so bad yet. So let's do something now. Let's make it a little bit more complicated. All right, how about, all right, I'm gonna make something up that I'm a little nervous it's not gonna turn out that great, but we'll see. Okay, let's do inverse cosine of 2x minus inverse sine of x equals pi over 6. Okay, yeah, why not? All right. So the bummer here is there's x in more than one term here. And not only that, it's embedded within more than one inverse trig function. So pick one to isolate. I think I'm going to isolate inverse cosine of 2x. And so that means I'm bringing the inverse sine of x to the other side. Okay, so let's focus on getting the 2x out of the inverse cosine. So I'm going to take the cosine of both sides. All right, so I've got 2x, which is good, equals. So on the right, what do I've got here? I have cosine of some angle, pi over 6, plus some other angle here, which I don't know what it is. I'm just going to call it theta. Well, remember, we can't distribute cosine across addition. We have an identity for that. So let's put in what that identity is. That identity is cosine pi over 6. Cosine, I'm going to just call inverse sine of x theta for now. So cosine pi over 6, cosine theta, minus sine pi over 6, sine theta. Okay. All right, well, let's actually put in what that theta is. So cosine pi over 6, cosine of inverse sine of x. That's not pretty. Minus sine pi over 6, sine of inverse sine of x. That's a little prettier. Okay, equals 2x. All right. So now let's simplify a little bit, because cosine pi over 6 is root 3 over 2. Cosine of inverse sine of x. Okay, that, I don't know what that is, but I'm going to create a triangle. And I know the sine of some angle, we'll just call it theta. The sine of some angle equals x over 1. So x over 1. And so I'm going to find the y coordinate by doing the Pythagorean theorem. So 1 minus x squared. So cosine of inverse sine of x is going to be square root of 1 minus x squared over 1. So I'm just going to write square root of 1 minus x squared. Minus sine of pi over 6 is a half. And sine of inverse sine of x, luckily, is x. Thank goodness for that. Okay. All right, so let's combine some like terms. If I bring the half x to the other side, I will get 5 halves x equals root 3 over 2 times the square root of 1 minus x squared. And I can multiply both sides by 2 just to make things a little bit easier. And now I've got to square both sides because I'm solving for x. So I've got to get that x squared out of the root. So let's square both sides. But remember, when we square both sides, we need to check for extraneous solutions. All right, so I get 25x squared equals 3 times 1 minus x squared. So 25x squared equals 3 minus 3x squared. So 28x squared equals 3. So x squared equals 3 over 28. Oh my gosh, this is not turning out that pretty. All right, so x is going to be positive or negative 3 over 2 root 7, or we could say plus or minus 3 root 7 over 14. Oh boy. So in order to check, you're going to go back to the original problem, which let's find where it was. This is the original here. And you're going to plug in for x 3 root 7 over 14 and check to see if the left side will equal the right side. So in other words, when you plug in to inverse cosine of 2, if you plug in x there, and then if you plug it in and then subtract inverse sine of plugging in that x, will you get pi over 6? Or the decimal approximation of that, and the same will be true when you plug in negative. So I'm going to pause this and check, and maybe you do the same, and let's see if either of these are solutions, if both or none. Actually, before you put it in your calculator, you hopefully caught my error here, which when you take the square root, hold on. So when you take the square root, so it's the square plus or minus the square root of 3 over 28. I forgot to keep the 3 within the square root. So it would be plus or minus root 3 over 2 root 7. And then if you rationalize, it'd be plus or minus root 21 over 14. Sorry about that. Okay. Or you can plug it in your calculator as square root of 3 over 28. Okay, so sorry about that. Now hopefully you can put it into your calculator. Okay, so hopefully you saw that the only one that worked was the positive, so root 21 over 14. All right, so that's probably a good place to end. Okay, so there you have it.